Hey guys, welcome back my channel The Learning Destinations. I'm your host Avinash, and today I'm happy to announce you that I'm gonna be a start a brand new series, Machine Learning from Scratch. So whether if you don't have any prior knowledge in machine learning, you do not need to worry guys. I'm here, I'm gonna be your machine learning buddy here, and I'm going to teach you machine learning from very basics to the advanced level. All I want you to show your patience level here because it is a vast topics, so you need to understand it very carefully. Okay, now in this sections I'm going to touch both the part like theoretical as well as the practical session. So for each theoretical sessions, after that there will be a one lab where I'm going to cover each topic as a practically. So one more request guys, if you haven't yet subscribe my channel, then please do it right now and press the bell icon. Now let's jump into the sections, and here is my first episode of machine learning from scratch. Hey guys, once again welcome back, and here I start machine learning journey from scratch, and this is the episode 1. So firstly we are going to learn about the linear algebra, because linear algebra is the foundations of machine learning. All kind of mathematical calculations we are going to use the numpy, and the same actions will be recorded in PyTorch and TensorFlow as well. Alright guys, so now I'm going to discuss about the roadmap of our machine learning journey, which I have divided into 3 categories. The first sections, which is the base sections, is mathematics sections, and here we are going to see all kind of mathematical calculation which is needed for our machine learning journey. So first section is linear algebra, and under this sections I am going to talk about the linear algebra. Then we will talk about the calculus. After that, we will cover the probability and statistics. Then we cover this sections, computer science. This is the base sections. Then we jump into the, uh, I can say that intermediate level, like mid sections. And here we will learn that how we can prepare the data set, how we can train the models, how we can build our custom models. And on top advanced level, we will see the specialized ML cases, and we will learn about the deep learning and the NLP. So this is our entire roadmap, and gradually I will take you from base to the top. Okay, so this is our roadmap of our machine learning journey. All right guys, so in this series first I explain the topic theoretically, and then I take you through the practical sessions, because I believe that once you understand theoretically, then practical sessions will be super easy for you. Now let's jump into the next sections, and here we are going to understand theoretically that why linear algebra is important for machine learning and what is its role in machine learning. Okay, so first of all we need to understand that linear algebra is the foundations of machine learning, and ML algorithm highly relies on operations like vectors, matrices, and tensors, and these operations are the characteristics of linear algebra. These operations does three tasks very well. One is data representation, second is transformations, and third one is optimizations. Okay, in data representations we are storing the data set as a matrices, and when I say the matrices it means rows and columns. Then we do the transformations. Linear algebra helps in scaling, rotating, or projecting data. Then third one is optimizations. Like algorithm like gradient descent use matrix calculus to minimize loss functions. Or in short, we can say that linear algebra provides the mathematical framework to process and analyze data efficiently in ML. Okay, so under this series, guys, we are going to see it practically that how the mathematical calculation help us to build a perfect ML model. All right, guys. So now in the previous sections, we have discussed about different operations in linear algebra. Now here we are going to closely understand what are these operations. So we are going to learn about the scalars, vectors, matrices, tensors, and in an advanced topic, we will be learning about eigenvalues and eigenvectors, singular value decomposition, which is also known as SVD, then matrix calculus, and which is highly used for gradient descent, and the last one is tensor operations for reshaping and broadcasting. Okay guys, so now I believe that so far now it's easy going for you, and you are not feeling like that it's difficult topic. Now we are going to understand one by one each operations. So firstly we talk about the scalars, and basically a scalar we denote it as a single number which has the magnitude but it doesn't have the directions, and we also call it as a zero dimensional quantity. Okay, for an example, like here you can see that x equal 25 is a single value, right? So we can call it as a scalar. Okay, and in machine learning, a scalar is generally used to measure the or represent the quantities like weight, height, temperature, speed, etc. And as a use case, we can consider as a representing single values in example learning rate. Okay, and now same thing, we are going to do some operations in the lab sections, and we are going to see that how the scalar works and how we can define through the NumPy, TensorFlow, and PyTorch. Let's jump into the lab section. Okay, guys, now let's understand it practically. So I'm using the Google Colab, and in order to save the time, I already prepared my notebook. Okay. Now we are going to talk about the scalar, which is having only the magnitude but no directions. Okay, so any single value which we define, we call it as a scalar. Okay, so here I already installed the NumPy taken as a NP. Okay, and if you are familiar with the Python language, then you can easily understand it. Okay, this is very basics. So here we can see that here we get the value of x. Okay, and here we can also get type. So it's an integer, right? If we point here the decimal like 50.0 something, the value will be, we call it as a float value. Okay, in the same way, so basically here I am showing you few basics operations that we can do it. Okay, so here the y value is 40, the same we are getting the value of 40, the y value, because we have already defined it. Now we can also get the type of y. We can do some mathematical operations here like x plus y, then it will give the sum of x plus y here. Okay, 50 plus 40, 50 plus 40, 90. Okay, now the same operations we can see through the PyTorch, and for that I imported the torch. Okay, we denote it as a pt, point torch. Okay, PyTorch, sorry. Here I need to correct the spelling. Okay, no worries, I'll correct it later, or let's correct it now. Why later? Do it now. Okay, then here I define the value. Okay, pt is just for like I'm importing the PyTorch. Okay, as a 25, so value is 25, and then I'm calculating what is the value of x underscore pt. Okay, which is 25 because I already defined it. So this is the operations in PyTorch. And having said that, at the starting of the course, that whenever I perform the operations in NumPy, I'm also going to show you in PyTorch and TensorFlow as well. Okay, so here we get the type integer as well, and the TensorFlow. Here I am importing the TensorFlow as a TF. I have already defined writing syntax into the TensorFlow a bit different. That every package, every library has different functions to write, right? So here we cannot define straightforward like we did it as a PyTorch. So here we need to give variable, okay, tf dot variable, and value we have defined here 35, and now we are getting the output of x underscore tf. Okay, so here in TensorFlow, we will be getting some additional details like data type. It is saying that it is in teaser 32. However, we can also define here the data type. Okay, so if we give something like that, d type equal, and then we can define integer, tf dot integer, something like that, tf dot integer 16, right? Something we can define like this also. but by default it takes integer. Okay, in the same way, if we want to define, then we can also define the float. Okay, tf dot float data type. So here we get the value 35, and now shape. Okay, so shape is this one. Shape is 0. Okay, because it's a 0 dimensional, it doesn't have dimensions. Data type integer 32, and then it is an array with a single number. Okay, all these values. Now I was talking about the floating point, right? So floating point, if you want to define, then you can put a decimal value here and then data type. Okay, tf dot float 16, and then we can get the floating values here. Okay, 30 pi, and here the data type, you can see that float 16 because we have defined here. And then some, we can also do some mathematical operations. You can do multiple operations. I just shown some value x underscore tf and tf underscore float. Okay, we need to see that where there is some problem, I think. Okay, let me fix it. All right, guys. So here we were getting the error. So here you, if you see the error, what it is saying that it is expected to be an integer 32. However, the float value I have defined here, data type float 16. Okay, here. Okay, so what I can do, I can, okay, let me delete this one. Let me delete this one. And here I'm going to insert one more row. Okay, I'm going to insert one more value here, and I defined here y underscore tf. Okay, and equal, I say tf dot variable, and then I'm going to put one value. Let's say I give 50. Okay, and I haven't defined the data type, so it is by default 32. Okay, so if I take ytf value, so now this data type is integer 32. Okay, so now it will work if I put it here y underscore tf. Okay, y underscore tf, because both the data type is same now, so it will support, we will be getting the sum. Okay, so here we are getting the sum 85 because x dot tf value is 85 and y underscore tf value is 50, right? So total we are getting 85. So earlier we were not getting, because here we have defined the data type float 16. So integer 32 plus float 16, somehow it was giving error. Okay, this is the part that this is how we can do the mathematical operations in a scalar. Okay, so a scalar mathematical operations can be done like this. Okay, I hope you will understand. Now let's jump to the vectors. All right, guys. So now I understand that you have clear understanding on the scalars. Now let's move to the vector. So basically, this is the second operations in linear algebra, and vectors is a one-dimensional array of numbers, and it has both magnitude and directions. Okay, so let's understand it like that. If we have numbers, we have basically a units in a 2D space 3 comma 4. Okay, so how we can denote it? Let me draw something in a paint, then I think it will be easy for you to understand. Okay, so if we have something 3 and 4, two values, two elements basically, and we can draw in x-axis and y-axis, right? So this is x-axis and this is y-axis, right? So here it's a 4 units, okay, in a 3 units, right? And it is a vector. Okay, like way you can represent the units in x and y axis. Okay, let's go to PowerPoint. So this is what it is explaining here. Position in 2D space 3 comma y, 3 units on the x-axis and 4 units on the y-axis. Okay. In the same way, if there is a negative elements, right, it means 5 units downward. Okay. So basically vectors are used to represent quantities that have both magnitude and directions, right? Force is having directions also along with the magnitude, right? We can say that force is in this directions or opposite directions, right? Forward directions or opposite directions. In the same way, we can also define velocity or the displacement. So, and as a use case, it is representing features in dataset like height, weight. Okay. Now let's understand it through the lab. Okay. So here we can see that it's a 2D space, and the same we are going to calculate we are going to do the mathematical calculations, and we are going to understand it through the mathematics point of view. Let's move. All right, guys, now it's lab sections. Okay, so vector, and it is a 1D, it means one dimensional. So here we have, again, we are taking as a numpy as a NP. Okay, and here we have defined the array. Okay, so this is a X array is having the element 2, 4, 6. Okay, so we are calculating the value of X. Okay, so here we have one array 2, 4, 6, which has element 2, 4, 6. We are calculating the length here. Okay, 3. It means this X, the vector X array is having 3 elements. And here we can define the shape. Okay, so here it tells the dimensions of array X. Okay, so basically in X is having these 3 denotes the elements. Okay, and here it's a number 246, so it denotes the element. I think it's pretty easy for you if you know the Python, right? The basics of Python, it's quite easy for you to understand. Okay, then here I have also explained a little bit about the index. Like in Python, when we start to counting the elements, the first index is 0, 1, 2. Okay, we cannot count like 1, 2, 3. We start with the 0 in Python. Okay, so here the index 0. So you can call these elements by calling its index value as well. Okay, so when we call the index value 0, we will get it the 2, the elements 2, right? Because that is what the positions of this index. All right. Now we are going to talk about the transpositions. Okay. Now transpositions, we will also understand it later on in a depth. So basically, in a short form, I can tell you, let's suppose that if there is a row is like 2, 4. Let me open it, paint. Here is a paint. So what I mean to say, so suppose if we have something like that, 2, 4, 3, 2, and then we transpose it, right? Then this column will become the row 2, 4, and then 3, 2, something it will come. Okay, the row become column, column become row, something like that. So this is the what the meaning of transpose. So here we have already the value uh, x values there, right? So we are transposing the x value. The x value we have already defined here, this. Okay. Now, if we call it, it will be remain the same. Okay. The reason in one dimensions, vector has no effect of transposing. Okay. You should note at this point in 1D space, the vector doesn't have any effect of transposition. Okay. That's why the array will be the same. Okay. However, if we define the nested values, right, nested matrix style brackets, then it has the effect of transpositioning. Okay. So now we have the y value, but we have given in a nested, it means we use double brackets here, but here you see in X, we use the simple array, right here. It is not nested, but in Y value, we have given the nested, these nested, okay. Now, if we do the transpositions here, y underscore t, this is we are defining as a variable, and here it's the value of y. Okay, then we are using it transpositions. Then okay, so there is something. Let me fix it first. Y underscore t is not defined, so we need to define y underscore t first. Okay, y underscore t is this one. So now you can see that here. Okay, I forget to run this command. So it converts this row into the column. This is what we have explained. If we have the rows, right? If we have the array, it converts it into the column. Then shape. Now it has 3 comma 1. What does it mean? It means it is having 3 rows and 3 rows and 1 column. Okay, that is the meaning of 3 comma 1. Now, as having said that, we are going to understand the same actions in PyTorch and TensorFlow as well. So here I'm importing the PyTorch. Okay, so this is the same value which we have seen just now as a x value here. Okay, 246. The only difference is that here I have used the NumPy. Now I'm going to use the PyTorch. Okay, so torch value, then we are getting the values array. Okay, in the same way for TensorFlow, we are getting the values. This one, okay, 246. Then data type, shape is 3. Okay, because it is not nested, it is only showing the 3 elements. Okay, yeah, like that. Okay, so far now we have understood the scalar and we have gone through the different mathematical calculations. Then the same actions we have seen in PyTorch, and second one is TensorFlow. Then we have understood that what is the vector. We did some mathematical operations. Okay. Now in next sections, we will be jump into the L2 norm. We will understand it. What is the L1, L2 norms? Okay. So that's all from this section, guys. And I hope you completely understood so far now the scalar vector, what is the role of algebra. Okay, and we will continue from here in the next episode. Okay.